All right. Hello and good morning, good afternoon, good evening to everybody out there, wherever you happen to be. My name is Gino Sigismondi. I am the Director of Shure Applications Engineering, Technical Support, and Training for most of the North America here. And yeah, thanks for joining us. I'm sure you, you know this already because you signed up, but today's webinar topic is going to be microphone techniques or microphone selection and placement, to be more specific, for houses of worship. This is perennially a favorite topic. We always have lots of good attendance when we do these, and we're going to cover a lot today. In fact, to be in the interest of full transparency, this is a pre-recorded webinar. So rather than hearing me talk live, you're going to hear me talk from the not so distant past when I actually get this thing recorded. The benefit here is that normally we always say, please hold all of your questions until the end, or we say type them into the questions pane and we'll answer them at the end. But since I don't have to talk at the same time as monitoring questions, go ahead and enter your questions in the questions pane at any time in the webinar. Again, mics are muted, so you can't ask them live, unfortunately, but type them into the questions pane as they come up, and I will do my best as the presentation is rolling to also get some of those questions answered. May not get to all of them, but I'll still be around for live Q&A after the presentation material concludes. So again, if you are not familiar with the GoToWebinar interface here, you can see there's, if you don't see the control panel, there's a little orange arrow probably on the right side of your screen. If you click on the orange arrow, that will expand the GoToWebinar button and you'll see the questions pane. And like I said, please use that one, not the chat pane. I can't monitor both, but if you put them in the actual questions pane there, I will be able to, like I said, get to as many of those as I can. And again, I will also be around for live Q&A at the end of the presentation too. So I will get this rolling here, and we will talk again on the other side. Thanks. So here's what we're going to do today. Microphone applications is a large topic, and we could go on for days and days about different things. But I wanted to see what we could give you that would be most applicable and most useful in the short amount of time we have together here today. So we'll start with some microphone characteristics, sort of the basics of mic technology, and not just for the sole purpose of being sciencey about it, but really just because understanding the basics of how microphones work and what those characteristics are the foundation for understanding how to select the right microphones. So that's another major section of today. We'll be looking at some common applications within the house of worship space and give you some pointers based on those characteristics for how to choose the right mic and how to place them. Again, it won't be an exhaustive list. There are lots of things we could go into. We have limited time, so we'll try to keep it to the major points. And then we'll also have a little Mythbusters section in there too. In the audio world, there tends to be a lot of myths about microphones in particular and how they work and what they can and can't do and how to best use them. So we're kind of hit a few of the major myths in there. And at the end, we'll just tag on just a little bit of some extra considerations when you want to go wireless, because that's, again, a whole nother layer of fun that brings to microphone applications. So let's delve into the characteristics here. So there are three important mic characteristics that we want to cover here. There are, of course, lots more specifications and things we could get into, but really when you're looking at choosing a microphone, these are the three things that are most important. That is transducer type, which is how the microphone translates sound waves into an electrical signal. polar pattern, which is how the microphone responds to sound coming at it from different directions, and frequency response, which is essentially, in a nutshell, how the microphone sounds, right? Or how it reproduces sound, I guess maybe is a slightly more accurate way of saying it. Remember, a microphone is really a very basic device, right? It really only has one job, and that is to, again, convert the sound waves, which is, the compression and rarefaction of air molecules, as that's what a sound wave is, right? A microphone's job is to take that sound wave and change it into a varying voltage that is analogous to the sound wave itself. So they're both waveforms, but they need to get from one domain into the other. And again, a transducer is just anything that can change one form of energy into another. So loudspeakers are also transducers, but they're doing the opposite of what a microphone does. They're taking that varying voltage and changing it back into variations in air pressure that we hear as a sound wave. In the radio realm, antennas converting a radio signal that is in the electrical domain into a wave form that can travel or be receptive to those. So again, an antenna would be another transducer, even our own eyes and ears, right? These are all examples of things that do that. So, and it's important to stress this when we're talking about the microphone, because sometimes, particularly with wireless systems, someone will buy a wireless microphone because they know they want their voice to be louder. And then they plug it in and they say, well, it's not any louder. I don't hear anything. And that's because, again, a microphone does not make your voice louder. A microphone just converts the sound wave that represents your voice into an electrical signal that can then be amplified, recorded, transmitted, whatever needs to happen after that. So the microphone is just that first component in the sound system that does that job for you. The three types of transducers we'll talk about today are dynamic, condenser, and ribbon. Again, there are many more. Historically, there's carbon mics and crystal mics and all kinds of other things. And even among these two, dynamic and condenser are by far the most popular. Ribbon is a little bit nichey, but we'll mention it just because there's been sort of a resurgence of interest in ribbon microphones recently. So a dynamic microphone is really actually a very basic device. It's a passive device, which means it doesn't require any power in order to operate. The three main components of a dynamic microphone are the diaphragm, the coil, and the magnet. So really, that's all you have is this diaphragm, which is a very thin layer of mylar, typically, that vibrates when sound waves strike the mylar. Actually, we've got an animation that shows this, probably easier to see there. And when the diaphragm moves back and forth, the coil of wire that's glued to the back of it also moves back and forth that around a magnet or in a magnetic field. And through the basic properties of induction, that means that as a coil of wire moves in a magnetic field, current is induced in that coil, and that results in the varying voltage that you see coming from the output of the microphone. And that's pretty much all there is to a dynamic microphone in terms of components. Sometimes there's a transformer and of course a connector on the output side, and the wires that connect it all together, but that's really it. And that makes dynamic mics have some of the characteristics that they're known for, right? Which is being really rugged, because it's a simple device. They are with no active electronics. They are very robust in terms of being able to work in different environmental conditions, high heat, high humidity, low temperatures. They can be dropped often without any sort of damage. So that makes them a really robust choice. They're also more affordable typically because of fewer components in there. And yet they still sound pretty good. I mean, probably the most popular microphone in the world is the SM58. That's a dynamic microphone, and it's been the most popular mic in the world since the late 60s. So I think that says something for dynamic mics and how good they can sound. Some of the downsides to a dynamic mic might be the fact that they can't be effectively miniaturized. They have to be of a certain size, maybe not as big as this SM7, but certainly as big as a Beta 58 might be, right? To have a decent sound quality, that's kind of, physical restrictions. So you never see really like dynamic lavalier microphones because you can't make them small enough to wear on your body and still expect them to sound good. And there's a limitation to the frequency response, which we haven't gotten to yet, but when we talk about the sound quality of a mic, again, some dynamic mics do sound really, really good, but they typically don't sound as good or can't sound quite as good as some condenser models do, and we'll talk about why that is when we get to condenser microphones themselves. So there are some limitations there, but again, in terms of the balance of affordability, ruggedness, and sound quality, you really can't go wrong with most dynamic microphones. Condenser microphone is a little bit more of a complicated device. You still have a diaphragm, of course, which is still mylar, often a metal layered, usually gold layered mylar, so it has a metal component to it. Again, very, very, very thin layer. But instead of having a coil of wire and a magnet, you have an electrically charged backplate that is behind the diaphragm, and some spacers to maintain a tiny air gap in there, essentially forming what is like a miniature capacitor. And as the sound waves strike the diaphragm, essentially what you're doing is changing the spacing of that air gap. And in an electric field like that created by that backplate, you end up with, again, the varying voltage that is the output of signal of the microphone. The output of a condenser element itself is typically very, very low. So you actually need some additional electronics inside of the microphone, referred to as the preamp. And you can kind of see in the cutaway, or the guts of this condenser microphone here, you can kind of see the preamp electronics in there that boost the signal level up and also alter the impedance, because the output impedance of a condenser element is also extremely high as well. So you need the preamp to do all of that for you. And this preamp, as it says here on the slide, requires phantom power in order to operate. So again, if you've never heard of phantom power, don't know what it is, it's a voltage that can, 48 volts is typical, but actually it can range anywhere from 11 to 52 volts of DC current that powers those electronics. And the reason it's called phantom power is because it doesn't require an extra power connection. It's not something separate you plug into the microphone. It just shows up on the mic inputs that of your mixer that you're plugged into, or your interface, or whatever is the next device. And most mixers, it's switchable. You can turn it on or off, but that's a very common phone call that we get here in the applications engineering team at Shure. Is someone maybe they had an SM58 dynamic mic, it was working great, but they decided they wanted to upgrade to a nice condenser gooseneck mic for their podium. They plug it in, they don't hear anything. Why is this mic not working? Typically, it's just because phantom power hasn't been turned on at the mixer. Some mixers, in fact, a lot of the more affordable mixers, only have one global switch that will turn phantom power on for all of your inputs. And the concern there sometimes is that, well, what if I'm not plugging condenser microphones in there? Well, phantom power will not hurt a dynamic microphone because it's balanced power. Essentially, if you look at the 3-pin XLR connector that are on most microphones, pin 1 is the shield, but pins 2 and 3 are your audio connections. And phantom power is equal on both pins 2 and 3, which means that when that voltage hits a dynamic microphone, no current flows, so it doesn't hurt the microphone in any way. So you don't have to be concerned about that. But anyway, what's good about condenser microphones? Well, because you don't have that big mass hanging off the diaphragm like you do in a dynamic microphone, and I mean, a coil of wire might not seem that much mass, but to a sound wave, which is relatively low energy, that's a significant amount of weight that it adds to the diaphragm. That limits what's called the transient response of the microphone, which is how quickly the mic element responds to sound waves coming at it. So here, what you're looking at is a spark gap captured on an oscilloscope from the output of both a condenser and a dynamic microphone. And the thing to really notice is that, again, the condenser, you can see that the spark, it gets to its peak voltage faster than the dynamic does, because, again, it takes more effort, I guess, for that dynamic element to get moving because of that coil of wire. And then also it takes a lot longer for it to slow down again, right? You've kind of got this ripple on the output side here that colors the initial frequency response. And that's why a dynamic mic doesn't necessarily sound as good as a condenser microphone. So condenser mics can be engineered to give you full range frequency response, right? 20 hertz to 20,000 hertz, which is the full range of human hearing, which a dynamic microphone can't do. And it's also flatter as well, which gives you a more natural frequency response, much more natural than you can get with the dynamic microphone as well. They're also more sensitive, again, because that less mass allows the microphone to be used for quieter sound sources and often at a somewhat greater distance, again, because that microphone is more sensitive. And they can be effectively miniaturized. So you can make a condenser microphone very small. Think of some of the theatrical lavaliers that are, small as a match head, right? Those are always condenser microphones because they can still maintain their excellent sound quality when they are that small. Downsides, well, they're a little bit more sensitive. They do have those additional electronics in there that require power, could make them slightly more environmentally sensitive. Although I will say that a common myth, getting ahead of ourselves into Mythbusters about condenser mics, is that, well, they're too delicate to use on stage. You don't want to drop them. Most modern condenser microphones, particularly ones from Shure, are engineered to the same quality standards as our dynamic mics. So many of ours are designed to be used in extremely harsh environments. So I wouldn't get overly concerned about that. They do tend to be somewhat more expensive than dynamic microphones as well. That's just something to think about. And they have that issue of needing power. Ribbon mics, just real quick here, are actually just another form of a dynamic microphone, except instead of having a coil of wire hanging off of the diaphragm is metal, right? It's a corrugated piece of typically some sort of aluminum or a metal aluminum layered mylar, something like that, right? And so when the sound wave strikes the element, the whole thing vibrates back and forth inside of a U-shaped magnet, and you get that varying voltage, again, through the properties of induction. Ribbon mics just have a really kind of unique sound characteristic to them that's often described as warm or dark. They can tame kind of the harshness of a particular sound very well. Not a lot of applications in live, which is sort of what we're talking about here today. So I'm not going to spend too much time on that, but if anyone has any specific questions about ribbon microphones, we can come back to that. So when we talk about how microphones pick up sound, that's where we get into what's called the polar pattern. And the polar pattern can be basically broken down into two different categories: omnidirectional microphones and unidirectional microphones, of which there are several different types. Now, an omnidirectional microphone is called that because it can pick up sound from all directions, as illustrated by the globe you see on the left there. So that means it doesn't matter which way you point the microphone, it will always pick up sound just about equally as well. Now, there are some good things about that, which means for people with sloppy mic technique, you can just kind of, hold the mic sort of generally within the, range of your mouth, and it'll pick you up, and even hold it upside down. But the downside is that it picks up everything. So particularly if you've got a lot of microphones on a stage, maybe it's a loud stage, that omnidirectional microphone will pick up everything, and that can be problematic. Also, omnidirectional mics tend to be a little more subject to feedback as well, and we'll talk about why that is later when we have a little Mythbusters section on feedback. But just know that omnidirectional mics are more susceptible than mics with some sort of a directional pattern to them. Unidirectional microphones, like the cardioid pattern you see on the right there, are very typical of like an SM58 or even this SM7 that I'm using. And the SM7 cardioid pattern is very consistent when you're directly in front of the microphone, or 0 degrees if you're looking at the graph version there. And you can see as you start to move off to the side, the response of the mic starts to drop, and that's what I can kind of do here. So now I've kind of moved to that 30-degree position, and you can already hear that the level has dropped. And if I go 60 degrees, it's even further off. And if I get all the way down to 90 degrees, I'm, probably about at least maybe 6 to 10 dB down here. Probably, yeah, closer to 6, right? So again, you can really hear that difference in pickup from the microphone as you move around. And I can't really do it too well with this microphone. That in the back of it, right? You probably couldn't hear me too much. And that's because that would be that dead spot of the microphone, or 180 degrees off axis. You're probably close to 25 dB down there. It's not null. It's not like there's absolutely no pickup, but there's very little pickup. So that raises an important point about microphones, which is, when you're using it, people often want to know how far away you can get from the microphone, but it's also a matter of keeping it in front of your mouth. With a cardioid mic, you've got a little bit of room to move around here, but you can very quickly lose it as you get off to the side, right? Something that will just reinforce over and over and over again is the best sound, the best performance you'll get out of a microphone is when you're close to it. And that doesn't mean you need to be right on top of it like this, but you typically, want to be within 6 to 12 inches of a microphone to get the best sound out of it. And we'll talk a little bit more about why that is in the Mythbusters section. Again, there are some other types of patterns here. So you can also go to a supercardioid pattern microphone. Now I'm going to very quickly do a plug and unplug here so I can show you what a supercardioid microphone sounds like. 1 second. Okay. So now you should be hearing me on a Beta 58. Sorry, that's probably in the way there. Let me move that out of the way. So this is a Beta 58A dynamic microphone that is a supercardioid pattern. Now you might notice I already seem louder than I did before, and that has to do with the type of magnet that is used in a Beta 58 that actually makes the microphone more sensitive. I don't want you to think that, oh, supercardioid mics are louder than cardioid mics. That's just a function of it being a Beta 58. But for illustrative purposes, you can see now as I start going around to the side, this sound starts dropping off a lot faster. I have to remember to stay in the pattern here so you can actually hear me when I do that. So again, a supercardioid pattern is even tighter than the cardioid pattern is. So what that means is that the drop off happens much quicker as you start spinning away from the mic. So when you're 90 degrees off axis, you're already like 10 dB down, and you can hear that drop pretty dramatically when you're down here. But something of interest, the supercardioid pattern, is you'll note that instead of having its angle of greatest rejection being 180 degrees behind the microphone, it's actually, there's sort of two lobes that are right at some slight angles off from the back. So you can hear there's actually a little bit of pickup right at the back of the microphone there. It's kind of dark sounding. You don't get a lot of highs because the body or the grill of the mic and all of that, the structure of it blocks the high frequencies, but you can still hear me back here because of that little area of pickup. But again, the null right about there. So again, you got a little bit of a different pattern you need to consider there. This is important too in placing like floor monitors on stage for a vocalist. If you have the typical sort of monitor blowing directly 180 degrees in the back of a microphone, that's great monitor placement for a cardioid pattern mic, but not for a supercardioid where you'd prefer to have it more off to the side. So you're dealing with that null. And then you can see the hypercardioid to the right there gets even more directional, and that lobe at the back gets even a little bit bigger because really what you're doing is you're stepping towards what is essentially a bidirectional microphone, which is the nulls are at 90 degrees and there's equal pickup at the front and the back. Now, one thing we didn't talk about with directional mics is what's called proximity effect. And proximity effect is a boost in low frequency response that you get as you get closer to the microphone. And I'm going to demonstrate this with the supercardioid because it has even more proximity effect than a cardioid, and because it's more sensitive, I'll be able to do a gain adjustment here. Because what I want to do is I want you to notice how the low frequency response of the mic changes when I get close to it, but I have to lower the gain so you don't just hear it getting louder. So this is at about 6 inches or so from my mouth. Now I'm going to bring it right up close. Hopefully there wasn't too much volume change because that was a total guess on it, but you can hear the darkness, which is that proximity effect. It's a bass boost that you get just from having the microphone this close to your mouth. But again, I'm going to go back, all the way back here and try to keep the gain coming up, and you should hopefully hear a much different characteristic in the low end, and that's what proximity effect is. It's a effect, it's not designed in, it's a side effect of having a directional microphone. All directional microphones have this. Omnidirectional mics do not. It doesn't matter what the distance is from your mouth, the frequency response does not change. I'm going to keep using this Beta 58 here for the next couple of things just because I think it's useful, especially when we get to the Mythbusters section. But before we get there, I do want to talk about frequency response, which again is just how the microphone sounds, but it is something that you can plot out on a graph. So if you've never seen one of these graphs before, what it's essentially telling you is that what you're looking at is the range of human hearing, at least in a newborn. I know I certainly can't hear that high anymore, and Cheryl could probably vouch for that too. You got 20 hertz on the low end, 20,000 hertz on the high end, as far as what humans are capable of hearing. And then the vertical axis is the output level, the measured output level of the microphone at different frequencies. So on the left, that's what we call flat frequency response, which is pretty obvious why it's called that. It's because the frequency response is equal. It looks like a flat line. It's equal at all frequencies. It's essentially what you put into it is what you get out of it, right? And this is the sort of frequency response that is wide and flat and very characteristic of a condenser microphone like a Shure SM81 or something like that. And you might look at this and think to yourself, well, wouldn't you want this all the time? Not necessarily. Keep in mind that different sound sources that you might be miking have different characteristics. In other words, not all sounds produce all frequencies, right? If you're miking, for example, well, actually pretty much any singer, I was going to say from a tenor on up, right? You don't really need anything below about 100 to 150 hertz or so. The human voice doesn't generate much energy down there, and you just end up picking a bunch of noise, stage noise, vibration, wind noise, P-pops, all that sort of thing is in that low frequency area. So if you are miking something that has significant low frequency content, that might muck things up. So as a contrast, we'll look at shaped frequency response, which again is called because the frequency response graph is now shaped instead of a flat line. And you'll notice here that you've got as a roll-off that already happens naturally within the microphone once you get below about 100 hertz, which again is great for vocal stage applications. Actually, pretty much all instruments except for bass, grand piano, organ, those bass guitar, those kinds of things. Pretty much anything else, you really don't need that kind of low frequency response. But you'll also notice a kind of a boost above the line where the microphone actually has more output when you get above 2000 hertz all the way up to about 6,000 or 7,000 hertz there. This is what we refer to as a presence peak. This is actually the frequency response of an SM58. And that presence peak is what gives the microphone its sound that people actually like about it. Just an interesting side note, the engineer that designed the Unidyne 3 cartridge that became the SM58 was disappointed that he was never able to get rid of that presence peak because he was trying to design the flattest possible dynamic microphone, but it turns out that peak there is what made it a hit. Why? Because that's where the consonant range is in human speech. If you think about it, consonants, which are S's, T's, P's, D's, C's, those types of things, those are what allow us to understand what's being said. And if the goal of a microphone, particularly in a house of worship application, is to make sure that the message is heard, anything that boosts that consonant range and helps with that articulation is particularly in a louder environment what helps it cut through. So the SM58 became a big hit with rock bands in the 60s because concerts got louder and louder, and that presence peak helped the sound of the vocal cut through. So we actually like that peak there because it helps where that's where the resonance in the ear canal is around 4K, right? Because that is where the intelligibility that allows us to communicate is. Vowels actually don't matter. That's why when you whisper, you can understand what people are saying, because vowels are when you whisper, you're essentially just not creating vowel sounds, you're only creating consonant sounds. And then again, there's a dip above 10K, which is also good because again, frequencies above 10,000 hertz, if you do reproduce those, they might sound a little bit more natural, a little bit more real, but they offer nothing in terms of intelligibility. So in terms of just being able to understand or get a real full character of what's happening, you don't necessarily need those. But again, for studio, for recording applications, for higher end things, it might be useful to have those there. Ultimately, what you want to do is match the frequency response to the sound of what you're picking up. And so this kind of gets into what I was talking about earlier, right? Where if you look at different frequency response of different types of musical instruments, you can see that not many of them have fundamentals that go much below 130 hertz, right? You've kind of got, cellos, bass drums, maybe a tenor sax might get down there. Of course, organs and pianos are very full range, right? Condenser mics might be a good choice for those. But a lot of other instruments don't need that low frequency response. Or maybe if it's something like kind of annoying frequencies of a trumpet are in this, range here, which is, the 4,000 hertz or so, where that actually kind of hurts your ears, and maybe you want a mic that isn't as sensitive there, like an SM58, maybe a ribbon mic would choose it. So that's why when we get asked often, what's the best mic for X, it's like, well, it really depends, right? It depends on the kind of sound that you want to get out of it. And that's why it's important to understand these characteristics. The last thing, just real quick here, that we want to mention is, again, the electrical output of the microphone. It's just important to understand that you want to plug mic outputs into mic inputs and line outputs into line inputs and not mix those two up, right? If a microphone is meant to go to a microphone input that has enough gain to bring it up, right, to bring the signal up to something usable. If you end up using plugging a microphone into a line level input, you won't get nearly enough signal to barely even hear the microphone at all. Vice versa, if something you're using has a line output, you don't want to use the line output into a mic input because that will distort it, right? So the chart on the right is basically just kind of giving you an idea of the different signal levels in dB, like a dynamic mic versus a condenser mic, the KSM44A, versus a mixer, which would be, 0 would be considered line level output. And then these are all just levels that are below that, right? That's the most important thing to consider. And the other thing you need to understand too is that a connector itself doesn't indicate a signal level type. It doesn't have anything to do with the impedance or the signal level. XLRs could be mic, they could be line level, quarter inch can be aux level or instrument level. So you don't necessarily associate the type of connector with the signal level. That's something you need to look at independently. Luckily, most modern equipment, mic mixers and things you can buy are kind of already designed with these basic use cases in mind, so you typically don't have to worry about it too much. But if you're starting to do things like trying to connect your mixer to a home stereo system, or your wireless mic to a home stereo system, or trying to plug a mic into a guitar amp, that's where these things kind of get a little bit weird. But for most part, mic output to mic input, you'll be good, as we were supposed to discuss on this slide, so I'll keep going. And of course, don't forget about the physical design of the microphone. Microphone comes in all different shapes and sizes for all different applications. Handheld, lavalier, headset, side address, end address. There's endless physical variations. And there's no right answers. There's just pros and cons to each, which we'll discuss when we get into the application section. But first, a little bit of myth busting. We'll go through this quickly. So, myth number 1. Some microphones have better reach than others. They can pick up sound at greater distances. I was going to actually put a poll in here where we could see what the audience thinks on this, but I figured in the interest of time, we'll just keep going here, because the answer is kind of given to you, right? Of course, it's a myth, right? Microphones, again, are just, I mentioned earlier, they're designed to do one thing, and they're really essentially a measurement tool. What the microphone is doing is measuring those variations in air pressure that are sound waves, right? They don't do anything actively to go out and capture sound. Microphones can't work like a telephoto lens, right? Or a zoom lens, where you can go in and make something appear to be closer visually. Because sound waves are so much bigger and longer than light waves are, there's no way to practically make a microphone that can do that. That's all it can do is hear what it hears that's right in front of it. So a common rule of thumb I tell people is, like, if your ear can't hear it, then the microphone's not going to be able to hear it either. And again, why we talk about microphones not being able to reach out and get the sound, what that ends up meaning is that as you move the microphone further from your mouth, the sound level drops. It follows what's called the inverse square law, which means that every time the microphone distance doubles from the sound source, the output signal of the microphone drops 6 dB, or the voice level drops 6 dB. And you can hear that easily. Again, if I bring the microphone up to, that's probably 2 inches from my mouth at this point, and if I double it to 4 inches, let me see if I can do this correctly. Okay, that's about 4 inches away. Not very scientific, but you can hear that that's about a 6 dB drop. If I double it again to 8 inches, probably about like that, now it's a lot quieter. And if I go back here, it's way down. Now I could try and compensate for that with gain on my mixer, but the reason you might not want to do that is if you're in a noisy environment, you're just going to end up picking up more of that noise. I thought we had a slide here. I guess we didn't. Picture there's a bunch of noise in between the microphone and the voice, right? And you end up hearing a lot of that. I guess I can illustrate that even just by snapping next to the microphone. Here, you can probably hear the snapping, but you can hear my voice pretty loud. But if I do this, now the snapping is much louder than my voice, right? So if that's any sound that is in between you and the mic, or even just ambient sound in the room, the further the mic is away from your mouth, the more you have to add at the mixer, which is the more of everything else you're going to pick up. Now, of course, directional mics can help with that. So that's one of the advantages of a directional microphone, is you can get it a little bit further away from the sound source and have it pick up less noise. And cardioid is better than omni, supercardioid is better than cardioid, and hypercardioid is better than supercardioid in terms of that. But the benefits are small. You can't really get that much further away. If you go from a omnidirectional mic to a cardioid mic, you can be essentially 1.7, I believe the figure is, times the distance away for that same sort of direct to ambient sound ratio. So it doesn't make a huge difference. The other reason to stay close to the microphone instead of having the microphone further away to try and reach out sound is because you can get something that's called comb filtering from reflections. So particularly, this is important to keep in mind when the mic is on a podium. If it's too far from your mouth, you actually end up getting multiple paths of your voice going to the microphone, right? So the mic signal goes directly, or the voice, goes directly into the microphone, but it also bounces off the podium or maybe an altar, and that arrives out of phase with the original signal, and the frequency response ends up looking like a comb, like you see on the right side here. That's why it's called comb filtering. And that just sounds really bad. It's a very hollow kind of sound that's just really not
pleasing. You want to, again, avoid that by keeping the mic closer to your mouth. Myth number 2, our pastor moves around at the podium, so we decided putting more mics on the podium will give us better coverage. Again, this is a definite no-no because, again, comb filtering, right? If you have 2 microphones picking up the same sound source at different distances, when those 2 mic signals are combined back again at the mixer, you get this comb filtering. So that's why you really don't want to have multiple microphones there. If you have a problem with someone who wanders or has poor mic technique, and they do this sort of a thing a lot as they're walking around, there are 2 solutions. One, you can use 2 microphones, but then you want to use them with what's called an automatic mixer, which is a mixer that can actually is smart enough to know to only turn on 1 microphone per sound source. So if it determines that 2 mics are picking up the same person talking, it only turns on one of the mics. And if that person wanders closer to the second mic that's off, it'll just seamlessly, without anybody even being aware of it, switch to the other microphone. So you get the benefits of a greater area of coverage from multiple mics, but you don't have to worry about these comb filtering issues. The other solution, of course, is a wireless head-worn mic or lavalier mic, because then the person can walk wherever they want. The microphone placement stays consistent. So we like to talk about what we call the 3-to-1 rule, right? When you're using multiple microphones, that means that for any unit of distance a mic is from a sound source, the next adjacent mic should be 3 times that distance away. So in the case of a choir application here, where is a very common application for more than 1 mic. If we have 1 mic 3 feet away out in front of the choir, the other mic should be 9 feet apart from that initial microphone, and that will prevent you from getting comb filtering on your choir mics. We'll talk more about choir miking in a minute. And myth number 3, if you're having feedback problems, you need to get a different microphone. Of course, that's not true. The microphone often gets blamed for being the cause of feedback, but it's not. Microphones in and of themselves are not responsible for feedback. Feedback is a loop that occurs when sound that gets picked up by the microphone comes back out through the loudspeaker and gets picked up by the microphone again. That's what causes that squealing, howling, annoying sound that we think of as feedback, right? And yes, of course, if you unplug the microphone, the feedback stops, but if you unplug the speaker, the feedback stops too. So that's what we mean about saying that it's not, just the microphone's fault. The best way to avoid feedback is microphone technique or mic placement. So let's look at the steps here. And I'm going to switch back to the other mic because now I'm getting tired of holding this one. 1 second, bear with me. Okay, I'm back. There we go with my SM7, which I love. Okay, here we go. So, again, we can't beat on this topic enough, right? Move the microphone closer to the talker, right? If you are getting too much feedback, that is the cheapest and easiest way to eliminate feedback is just get people to move the microphone closer to their mouth. The other way, of course, is you can move the loudspeakers closer to the listener, because the closer the loudspeaker is to the listener, the less you have to turn it up, but that's often not practical and or possible. Keeping the number of open microphones to a minimum always helps. Don't turn on all the mics all the time. Just only turn on the ones that need to be on, and that will help your gain before feedback. Keep the loudspeaker as far from the mic as possible. And again, then we get to using directional mics, right? And directional loudspeakers, of course. That is a benefit. As I mentioned, cardioid mics are less susceptible to feedback than omnidirectional are. And then equalization or automatic feedback reducers, which are other devices. You can get DSPs that will help with that. But you should always try all of those other things first. In other words, this is meant to be an ordered list of things you should do when trying to maximize your gain before feedback. Don't just necessarily reach for the EQ right away, or don't just think like, oh, I'm getting feedback. I want to get one of those mics that doesn't have any feedback in it. There really isn't such a thing. So that's kind of your list there. And again, we will go very deeply into that next week. Okay, let's get into the meat of the matter. Right now, we're just going to plow through a list of applications and talk about the types of mics that are good for those, starting with the Lectern and or podium application, right, which is probably the most common microphone application in houses of worship, maybe next to the wireless lavalier microphone, but this has the distinct advantage of being cheaper than a wireless microphone. Anytime you add wireless components, you're certainly driving up the cost. So I always And I'm sure our sales department would hate me saying this, but if you don't need to be wireless, then don't buy a wireless. These microphones are very good, and you've certainly reduced your complexity, provided you are standing at a lectern and delivering your words. So these are almost always going to be a type of gooseneck microphone, which is what you see pictured on the right there. These are typically condenser microphones, which are useful because they're smaller, right? I mean, yeah, we've seen people put SM58s on big honking goosenecks and bolt that down to a podium, but it's not very pretty, right? So these microphones are much less obtrusive, and the fact that they're a condenser means you can make them smaller and still have them sound good. They are typically unidirectional, and that's an important, I guess, kind of side note here. Again, when you have the issue of the sort of wandering pastor that doesn't stay in front of the microphone, you'll often get, I'll often hear from people, oh, we should use an omnidirectional microphone instead because our pastor wanders a lot. Well, that's not going to help you. Remember, the only difference between a cardioid and an omnidirectional microphone is the fact that the omnidirectional mic picks up 360 degrees around the microphone. But if you wander off to the side like that, it doesn't really help you. You're still getting quieter because you're moving too far away from the microphone. So unless your pastor wanders to the other side of the lectern and speaks into the back of the microphone going to an omnidirectional mic, it doesn't really help there. But you would certainly want to stay away from a supercardioid pattern. A supercardioid pattern gooseneck mic is often not the best choice because, again, any sort of movement to the left or the right can cause a massive drop off in signal. So cardioid tends to be the way you want to go there. Again, that shaped response is useful because it helps with the articulation and gets rid of low frequencies that you don't necessarily need. So that's typical sort of reasoning you would go with those sorts of microphones for that application. It also mentions that mic placement, you kind of want to be about a foot away from the mouth. You want to try to avoid going any further than that, simply because the signal levels gets lower, gets weaker, and you open up more problems with feedback and ambient noise when you go too far away. Aimed towards the mouth, of course. And this is kind of an interesting one. A few inches off center. A lot of people don't realize that, and I should have had a gooseneck mic, a condenser particularly, to illustrate this. But if you want to avoid that P popping, the P's, T's going through the system, people often, again, think that, oh, maybe I just need to put a bigger windscreen on the microphone. But the best thing to do is actually put the mic aiming towards the side of your mouth, right? And that is because the breath blast that caused that boom or that P pop, it's a blast of air that goes straight out of your mouth. So when the mic is right in front of your mouth and you probably can't hear that too much, especially over a webinar with the codecs and everything. But to minimize it, if you go here, you get far less of it, right? So you do, I always cringe when I ever see anybody step up to a podium and they grab the gooseneck mic and put it right directly in front of their lips. It's typically not what you want to do. You definitely want to have it off center a little bit. And again, general tips, one mic on at a time. Again, the gooseneck mic is nice because it minimizes those reflections. If you have the mic too low, too close to the podium, too likely that you'll get reflections. Pop filters are always a good idea, and a shock mount, of course, especially if you've got someone that likes to bang on the lectern a lot. Now, in an altar application, which is typically lower, different sight lines, you often don't want a gooseneck microphone sticking up off the top of that. It's pretty unsightly, kind of ruins the whole aesthetic, I think. And that's where you might get into more of what's called a boundary or surface mount microphone, which are small flat microphones that are actually just lay right directly on top of the surface where you put the microphone. And there's a couple advantages to that besides just the visual one, but also from a sound perspective, you don't have to worry about that reflective comb filtering because now the microphone is on the surface. So the direct sound waves from your mouth getting to the microphone arrive at the same time as the reflection would happen right at that boundary, right? So there is no comb filtering that happens with boundary mics. So they are definitely a great choice when you need something to kind of stay out of the way. Again, condenser mics, of course, because you need that sensitivity and that small size, and cardioid is, again, the way to go. Omni doesn't really help you here. And here's just kind of some sort of basics of how to place one of those microphones. What is interesting is you do typically need to place them a little further away from the edge of the surface because you'll notice that cardioid pattern, if you look at the side view, is only about 60 degrees above the surface. So if you put it too close to the talker or too close to the edge of where the person is standing at the altar, they'll end up talking over the microphone. So you have to be far enough away so that you're within that 60-degree sort of vertical acceptance angle there. The other real danger of boundary mics is they can be covered, right? So you want to make sure you don't put anything down on top of that microphone that will block the sound from getting to it. And also surface noise as well, again, because it's on the surface. If you end up tapping things or just kind of hitting things, pounding on the surface, the microphone will be more likely to pick that up. So definitely watch out for that when you're using these. A little bit of just awareness that, hey, there's a microphone here, watch out for it, can go a long way. Now, of course, as I mentioned earlier, lavalier microphones are very popular. And you actually, I would say you probably rarely find someone that is willing to just stand there at the podium and not move around ever. And if you don't want to have a handheld that you're holding and you want to have your hands free, there are two options: the lavalier microphone or the headset microphone. Typically, condenser mics in either of these applications, because you want something that is small enough to be able to stay in place and not be visually obtrusive. In this application, omnidirectional is typically recommended, because now you don't have to worry as much about where specifically you place the microphone or which way it's pointing. The lavalier mic will pick up from any direction, right? And you don't have proximity effect, which is important, because when the microphone is right on your chest, there's a lot of resonance there, and that proximity effect of a cardioid mic directly in your chest can give it a too boomy of a quality that obscures the intelligibility. And also there's minimal wind noise and breath noise artifacts from that. However, you might choose a unidirectional mic if feedback is a problem. If your sound system setup is in such a way that it's a noisy environment and there's a lot of reflectivity and a lot of that feedback occurring, then you might choose to go with the unidirectional lavalier microphone instead. Typical rule of thumb for placing a lavalier mic is about 8 inches below your mouth. And what I like to do is, kind of do this with my thumb and forefinger, put my thumb under my chin and go, the lavalier microphone goes there. That's typically a good way to think about it. Again, remember, if you're using a unidirectional mic, you have to verify that it is pointed in the correct direction, up at the mouth and not off to the side. Pop filters are essential, particularly with unidirectional types that tend to be a little more sensitive to that. You really want to have that windscreen on there. Also make sure you're kind of clipping the cabling so that it's not, loose or might get tugged or something like that, or just unsightly. And of course, if you are using Lectern mics, remember, we want to avoid that comb filtering of multiple mics. So if someone steps up to the podium, make sure you mute one or the other. It doesn't really matter which one, but you don't want to have a lavalier mic and a Lectern mic active for the same talker at the same time. Head-worn mics, again, obviously what they are, tiny condenser mics, typically omnidirectional. And in this case, the gain before feedback is even less of a problem because the microphone is right there up at the corner of your mouth where you would like it to be. There are dual types, single ear types, depending on aesthetically what you like. I feel like the dual ear types are a little more secure, but the single ear types are definitely much lower profile. These are a really great choice for gain before feedback and sound quality. We are big fans of head-worn mics here at Shure. And if given the choice, if you have the option to go between head-worn and lavalier for any sort of sound reinforcement application, if you can convince whomever you need to wear a mic on their head or their face, the head-worn mic is definitely the way to go. Not only because of the gain before feedback issue and just a stronger signal, it's also more consistent. Keep in mind, with a lavalier mic, when you move your head, the lav mic doesn't move. So you get that same effect that you hear when I do this in front of my handheld mic, happens with a lavalier mic. But with a head-worn mic, where the microphone is here, right? When you move your mouth, move your head, the microphone moves with it. So it's always going to be the best, most consistent sound quality from a head-worn wireless microphone, versus a lavalier microphone. Switching gears a little bit, I know we're going through these fast, and we want to look at choir microphones here now. Choir microphones, again, a lot of condenser mics used in house of worship applications, if you haven't noticed. But for choir miking, where the microphones tend to be even further from the sound source, you want to use that condenser microphone. Also, now we're really looking at flatter frequency response needed here, because you want to pick up sort of that full range of voices in the choir. And the further away a microphone is from the sound source, the more important it becomes to use that flat frequency response, because you have less proximity effect to kind of balance out that presence peak. And also, in terms of feedback, the presence peak will start to feedback earlier when the mic is further. So you can typically get better gain before feedback from the flat response mic, which is definitely an issue when it's going to be further away here. There are a couple different options when you're looking at these microphones. On the right is more of a hanging mic, which is good for low profile applications. Sometimes people want to upgrade to something with a little bit more studio quality sound, like you see with the KSM 137 on the left. Either one is appropriate for miking. It just depends on, again, what you need from a visually aesthetic point of view and what your budget is and those sorts of things. But again, we want to look at that 3-to-1 rule, right? So when we're putting, because most choirs, unless they're really, really tiny, are going to need multiple microphones, right? So to avoid that comb filtering, again, keep the microphones about 2 to 3 feet out in front of the choir and 6 to 9 feet away from each other. You typically want to angle it so that the mic is pointed, the most sensitive part of the mic is pointed at the back row of the choir, because that helps give you a more balanced sound. If you point it down to the front, you're going to hear the front row much louder than everybody else, but keeping it pointed at the back row, which is furthest away, again, gives you that nice balanced, even sound of the whole choir. Now, a common question we get is like, well, what if the pipe organ is right behind the choir? We seem to get more of the pipe organ than anything else. Well, that is a problem. Like I mentioned earlier, microphones, they only hear what you hear. So if you're standing there and you hear the pipe organ louder than the choir, the microphone is also going to hear the pipe organ louder than the choir. The only way to really minimize that, besides physically moving the choir somewhere else, is to use more mics closer into the choir. And that's an unfortunate side effect of going closer in, is you do need more microphones to get even pickup, but the only way to get better, more direct sound of the choir is to keep the mics closer. It's a sticky application to get just right. Another thing we get asked about quite often is microphones for the congregation. That again is actually going to be very similar to what you would mic a choir with. However, I have to reiterate this over and over again, that this should only be for capturing the sound of the congregation for broadcast or recording or webcasting. If you try to put microphones on the congregation and reinforce that through the loudspeaker, it's a recipe for feedback, because the microphones are typically in the ceiling too close to the loudspeakers, far away from the congregation, because you're trying to pick up a whole lot of people, and feedback will almost definitely occur. If the reason you're putting mics on the congregation is to try and get some sort of individual talkers, testimonials, things like that, you kind of have to use what we call the Oprah Winfrey method, which is a wireless handheld mic that you have runners delivered to those people that want to talk. And when people think, I can't believe that's the only way to do it, the way I answered that, it's like, well, Oprah has more money than just about anybody on earth. So if there was a way to throw money at this problem to fix it, she probably would have come up with it. That's, again, good thing to keep in mind there. Now, when we talk about musical applications and outfitting the praise team, that's a whole nother webinar that we just don't have time for today. Just some general things, right? Vocals for vocalists, singers, praise team leader, etc. Handheld or head-worn can work here, but something that is close to the mouth. Again, dynamic or condenser, largely depending on your preference. Unidirectional, that sort of a thing. Good shock mount when you have a handheld, so you don't hear that handling noise. Instruments there, you can kind of see some of our general recommendations. I don't really want to go through these in detail here because we're running short on time, but we do have some great educational material on our website, including microphone techniques for live sound reinforcement and microphone selection and placement for houses of worship that go into great detail on how you use some of these principles to choose mics for different musical applications. Finally, special considerations for wireless. Again, this is brief. Wireless is a huge topic, and we have plenty of other webinars on our webinar page on getting into the nitty-gritty of wireless. But some things I just want to leave you with to think about here. The most important questions you have to ask, particularly that first one, is the most important, which is how many channels. When it comes to picking a wireless microphone system, the main thing that differentiates less expensive systems from more expensive systems is how many you can use in the same room at the same time. So if your needs are modest, you only need 2, 3, 4 wireless mics, an entry-level, more budget system might work. But if you're imagining someday outfitting, your praise team with 12 channels of wireless and 10 channels of in-ear monitoring, you better be thinking a lot higher end. So you always have to have that thought process when you're buying a wireless, is how many channels do we want to use? Analog versus digital, that's almost kind of a no-brainer now, because just about all wireless mic systems are digital, except for some of the most affordable ones. But digital wireless does offer the advantage of better sound quality that sounds almost just like a wire versus analog systems, and some more advanced feature sets and just kind of smarts in terms of how the wireless works. Again, you want to look, rechargeable batteries have become a much better option now, which saves you money in the long term, so I would definitely recommend looking for that. Rack mountable is definitely an advantage when you're using a larger number of systems, and that is because of this. Our tips for improved wireless microphones operation. Whenever you're using more than 2 receivers, sorry, I skipped the first one, position antennas for best line of sight. That's really, really critical. You want to have your antennas in the same room up high so that you can see them. You don't want to have 300 or 400 or 1,000 bodies in between you and the antennas. So get those antennas up in the air, get them line of sight. To be able to do that, you need to use a rack mount receiver that allows you to remote mount antennas. And if you have any more than 2 receivers, you want to use antenna distribution that allows those receivers to share one pair of antennas. So you don't have a whole forest of antennas sticking up in the air, but just 2 antennas that are shared. Also, you want to scan for best frequencies. Most modern wireless receivers have the ability to identify a best frequency for you. Again, common troubleshooting call we get from someone who bought a wireless mic, they plugged it in, turned it on, and they're getting dropouts. The number one cause of dropouts in a wireless mic is interference. The best way to make sure you aren't getting interference is just use the receiver to scan for you. And then if you're using multiple systems, you need to take the extra step of ensuring that your frequencies are compatible with one another. And again, you look up our webinars on frequency compatibility, it's a whole thing, but it's just something to be aware of. Picking frequencies for your wireless is not a random hunt and peck, let's try these and see if it works. It actually needs to be actively coordinated. A lot of our smarter, newer systems can take care of that for you, but you definitely want to be aware of that. And then of course, make sure you always have fresh or charged batteries. And we highly recommend locking transmitters during use so that they don't accidentally get turned off. And then guess what? No audio.
Okay, welcome back, everyone. A lot of good questions came in during that playback there. Tried to get to most of them. Check that out if you are interested in seeing what sort of questions were asked. As mentioned, I will hang out here for a few more minutes. If you have any other questions you would like to type into the questions pane, I will be happy to answer those for you at this time. There's actually one here I didn't get to yet, which was a question about automatic microphone mixers. If you remember, that was the device that automatically mutes or unmutes microphones. Actually, attenuates is a better word for it, based on whether or not someone is actually addressing that microphone, which improves overall sound quality. And the question specifically here was with automatic mic mixers, is there a delay adjustment that will make them turn off and on slower or faster? And the answer to that actually kind of is like in a lot of things audio, it depends. It really depends on the model. The most popular auto mixer that we have is the Shure SCM810, which is actually not adjustable. The whole design philosophy with that device was to make it as simple and as much of a no-brainer device as we possibly could. So therefore, all of the threshold adjustments and the turn on, turn off time is all preset. Actually, that's not totally correct. The turn off time, or what we call the hold time, can be adjusted. There's 2 different values there that you can choose for how long the mic stays on once it thinks the person has stopped talking. But the activation time is within 4/100ths of a second. It's very, very fast because again, the whole idea was you don't want to clip off words or anything like that. So with an SCM810, it barely misses anything ever. It never does. Most people are never aware that they're even hearing an automatic mixer when we're using the SCM810. So hopefully that answered that question. Let's see. We have a question about picking up audio at the baptistry. Specifically, the question was around using like a boundary microphone, like we saw, that kind of like you might use on an altar, right? The issue with those is that you need a surface to put that on. It should be 2x2, actually even 3x3 is better, simply because the reflections are kind of required for that microphone to work the way it is designed to. And obviously you're not really going to be able to put a gooseneck microphone in that location. Probably the best option would be some sort of like a choir microphone. Like our MX202, for example, that hanging microphone. If you have a place to hang the microphone down close to the area where the speaking or talking is taking place, that would really be the best thing to do. Shotgun mics were brought up, but we really don't recommend using shotgun mics for any sort of live sound situation.
Those really are designed for broadcast, sort of straight to air, straight to tape. Tape, who records with tape anymore? Straight to video, some sort of a recording medium or something like that. They really don't work well for live sound applications. So again, that choir mic would be a good choice there. Let's see what else we got here. What would be the best gain structure recommendation for a Shure BLX-D? There's no BLX-D, so maybe you just mean regular BLX, which is the analog wireless microphone system. So gain structure on a wireless mic is tricky in terms of like it can be different for different types of systems, especially analog versus digital. It's kind of handled differently. But your basic rule of thumb, in fact, I'll quote a former co-worker of mine who liked to say it this way. On most wireless mic receivers, you've got a string of LEDs that show you what the input signal level is coming in. Some things like BLX, it might just be a tricolor LED, like it kind of goes green, amber, and then red when you're getting in distortion. Higher end systems actually have like a little ladder of LEDs that go up as you talk into the microphone, right? Kind of like a VU meter or something. The philosophy is that you paid a lot of money for those LEDs and you want to light up as many of them as you can. What that means on like a BLX system, right, is that means there's a gain control on the body pack. When someone is talking into the microphone, you want to turn that gain control up high enough so that that LED is green and maybe even just tickling the red occasionally. When the pastor or whoever's using the mic gets really excited and really starts yelling, it's okay to see that red just a little bit. And that means you have the best or highest amount of gain right up front through the mic system. What you don't want to have is the gain be too low. So if you're not lighting up enough of those LEDs, you're going to have to make up for gain at your mixer, which is going to boost noise, right? It kind of degrades your signal to noise ratio. So always think about getting as much gain up front as you can, of course, without going into distortion. Okay, what else we got here? I missed the handheld Singer mic info. Is the SM58 a good capsule for that application? Short answer, yes. We could go into a lot more detail there, but there's kind of a reason the SM58 is basically the best-selling mic in the world every year for like the last 50 years. It does work well for that application. Are there others? Of course there are. Microphone sound quality is a largely personal choice. And there may be others that suit the particular voice better, but when in doubt, you're never going to go wrong with an SM58. In fact, I'll say a saying I've seen used many times is, the SM58 may not always be the best choice, but it's never the wrong choice. So think about it that way. Is it true for vocal mics for worship leaders that it's better to demo a variety of mics and match the mic to the person rather than just relying on mic specs? That is a great question and a great point. Mic specs are useful for getting an idea of what a mic might sound like and what it might be good for, but there's absolutely no substitute for trying it out live if you can. Right? It's sort of like, reading a recipe for something you might be making for dinner. You can get an idea from looking at the recipe of probably what it's going to taste like, but until you actually put that bite of food in your mouth, you're going to have a hard time knowing if it's actually something that you like to and enjoy eating. So definitely live demos is always the best. Question here about what is the best mic for miking a piano. With most acoustic instruments like that, so whether it's a piano or an acoustic guitar or anything that is not like amplified, like an electric guitar, something like that, or a horn instrument, a flat response condenser mic is going to be something you want to be looking at there. So something like a Shure SM81 or KSM 137, those are both examples of that type of microphone that are sensitive and natural sounding, which is going to capture the sound of that instrument directly. Good question. Let's see. We have a handheld wireless mic on the podium, and whenever the speaker taps on the lectern, it picks this up. Any suggestions to minimize this? I had a similar question earlier in the Q&A too from someone who puts a KSM8 on a floor stand on a hardwood floor, and they pick up the footsteps. The best thing you can do for that is actually try to get a vibration isolation shock mount. For the wireless, it's a little trickier. I don't think we make one that fits those handles because they're a little bit larger. For wired mics, there's the A55M.
For wireless, you might look at, I'm not sure how the gooseneck is attached to the podium, if there's some sort of way to insert maybe like a rubber pad or something like that, but you want to try and get some actual mechanical isolation from those, between those two devices. Where is the best place to where best to place boundary mic for a piano? We want to improve our dynamic SM58 hanging an inch over the hammers. Yeah, an SM58. I mean, again, like I said, it's never the wrong choice, but probably wouldn't be my first choice for piano miking because it's the opposite of what I just said about piano miking. It's not a flat response condenser; it's a shaped response dynamic, which works well for vocals and for electric guitar and things like that, but not so much for piano. So if you're going to put a boundary condenser mic in there, ideally you want to have two. You want to kind of place it over the hammers or just behind, and ideally you have one kind of for the over the higher strings and one kind of position towards the mid lower section of the piano. If you only have one mic, probably want to skew it more towards the higher strings. And the reason for that is because the longer wavelengths of the lower frequencies and the lower notes travel further. So if you have the mic skewed too far towards the low strings, then it's going to just sound bassy and dull. But if you go towards the high strings, it'll balance out a little bit better. And you might have to play around with it a little bit just to kind of see where it sounds the best, but that kind of gives you hopefully some idea of where to put that. Okay, well, that was the last question that came in, and it looks like we're actually over time here anyway. I will pause for just a few seconds, or probably not pause, I'll just babble to fill the silence just in case any other questions come in, but hopefully that was educational for you. There's also, if you go to the educational publications, actually the Shure Audio Institute, which is our training page on the website, you can find archives of all of our past webinars, maybe not all, but a lot of them, more than you could probably go through in a month. So plenty of extra learning to be done there. And also I want to call attention to, on that same page, you can find a link to our educational booklets, where we just published an updated and revised version of our audio systems guide for houses of worship, which takes the framework of what we talked about today and puts it in much more detail. So if you are interested in reading more about that, again, go to the under support, Shure Audio Institute, educational publication, audio systems guide for houses of worship. Take a look at that. And there is one more question, so I'll take one more question and then we'll wrap it up here. Placement of a KSM 44A for choir, is higher above the choir better? I think higher generally is better. And then I'm not sure exactly what you mean by higher, but what I like to do with choir mics is to kind of go up sort of above their heads and angle down a little bit towards their mouths. Again, you don't ever want directly overhead because sound doesn't come off the top of your head, it comes out of your mouth. So if you if you get it kind of again out in front, sort of even with the back row of the choir, right? Because the back row is furthest away but highest up, so you'll get that sound nice and direct. And then kind of as the pattern of the mic rolls off, this is of course assuming you're using the cardioid pattern, because the 44A has multiple patterns, but assuming you're using the cardioid, again, kind of even with the mouths of the back row of the choir and angled down slightly, should give you a good balance there. So good, nice. That's a nice choice for a choir mic. All right, so that takes us to the end. Again, thank you for joining us, and we will see you next time. Take care.